All right, so this video is going to be about graphing square root functions. So we're going to start with what we call the parent function. All right, again, the parent function, also known as the ancestor function, is where the function starts from. It's the most basic form before it's been transformed in any way, stretched, compressed, shifted. Another way to think of it, it's the most simplest form of this type of function. All right, and again, this is a square root function. So whenever you want to look at graphing a new function, a good place to start is table values. Okay, plugging in x values, trying to get a general shape of the graph. So if we do that for this function, we make a table values for square root of x. All right, we plug in -3, and right away we have an issue. What's our issue? Well, that's imaginary. It does not exist. So we just type in DNE. Right, and that's going to be true for any negative. Right, you cannot take the square root of a negative value. So your inputs have to be positive, all right, or greater than or equal to 0. All right, so starting at 0, right, square root of 0 is 0. Square root of 1 is 1. Square root of 2 is just that. It's the square root of 2, all right, which is approximately 1.4. And then 3 is the square root of 3. And 4, square root of 4 is just 2. All right, so what is this graph going to look like? Well, you plot the points that we have. So 0, 0, 1, 0, 4, 2, and I'm going to skip those decimals, but they're somewhere in between there. All right, and you could also, we know 9 is a perfect square, so we know 9 is going to be 3. All right, so I can graph my function. It's going to look something like this. This is the parent function. All right, the origin is the critical point in this case. Right, it starts at 0, 0. It's the initial point or starting point of the graph. Right, and from there it goes up 1 over 1, up 1 over 3, up 1 over 5. Okay, and so we get our graph of our radical. So really fast, let's compare, okay, a quadratic to a square root function. All right, so a quadratic, the parent function of a quadratic is just x squared. The parent function of a square root function is just rad x. The quadratic's in red, the radical, the square root function's in blue. And so they are almost inverses of each other. And what I mean by almost, it does reflect over the line y equals x, okay, but only half of it does. All right, so only this half does. This half would all be negative. All right, and so obviously it can't do that, right? We don't reflect this part of the graph because now that means that g of x would not be a function. All right, so we only, all right, we only graph the positive, the principal roots when we're graphing square root functions. All right, so just this. So we want to compare the patterns. All right, so on a square root function, or sorry, on a quadratic function, the red one here, right? We're going up 1 over 1. Then we got to go up 3 over 1. Then we got to go up 5 over 1. All right, we could go the same thing to the other direction, right? But we're only focusing on the right side here for the positive values of x, because for square roots that has to be true. What's the pattern for the blue function, the square root function? Up 1 over 1, up 1 over 3, up 1 over 5. So over here it was up 1 over 1, right? Up 3 over 1. Over here it's up 1 over 1, up 1 over 3. So they flip because they're inverses, right? Inverses, the domain and range switch. That's what's happening here. So when we're graphing radical functions, okay, or square root functions from the initial point, right, we can look to use that pattern of up 1 over 3, up 1 over 1, up 1 over 3, up 1 over 5. What happens if we just throw a 2 in front of these? Let's stretch it out. All right, so now, okay, it's up 2 over 1, up 6 over 1, up 10 over 1. So now the y's, okay, are doubling. Okay, same thing is going to happen here. The rise is going to double. But remember before, the rise was always 1 here. So now every time the rise is going to be 2. So now it's going to be up 2 over 1, up 2 over 3, up 2 over 5. Notice the overs don't change in either one of these cases. It's the up that changes, right? And so before in the quadratic, the ups were 1, 3, 5. So those changed to 2, 6, 10. Okay, on the square root function, the up was always 1 for the parent function. So when I stretch it, now it's up 2. So it's always up a over 1, up a over 3, up a over 5. So that's the pattern that we want to pay attention to. All right. So if a is 1, what's the rate of change from the critical point? As I just said, the rate of change is up 1 over 1, then up 1 over 3. Right? Then up 1 over 5. Okay, but if a is n, then it's up n over 1, up n over 3, up n over 5. Notice the overs never change. It's the up that changes. And the up is always going to be the same as whatever a is. If a was negative, it's down. All right, so A, H, and K, what do these do? Okay, so really quick, K moves the graph up and down. Notice what it's moving. Focus on that critical point. All right, when K is 0 and H is 0, the critical point is 0, 0. As soon as I make K 1, critical point is now 0, 1. Okay, H is going to move it left and right. Right, as H gets bigger, the graph moves to the right. So H is 5. Okay, now the critical point is 5, 0. All right, if I make H negative, let's make it negative 3. Now the critical point is negative 3, 0. So the critical point is always going to be HK, right? Let me make K1. And so we can see that the critical point should be negative 3, 1. Double check the graph. Negative 3, 1 is the critical point. Right? A is going to stretch the graph or compress it. It's going to control that rise. It's going to be up A over 1, up A over 3. Right? So if A is a fraction, right, if we make A 1/2, okay, it's still going to be up 1/2 over 1, up 1/2 over 1, up 1/2 over 3, up 1/2 over 5. All right, if A is negative, what happens? Now we just reflect it. Okay, what are we reflecting it across? We're reflecting it across the line y equals k. All right, the horizontal line that goes through it. So we just reflect it over that point there. All right, so now let's get to some work here. So type in the radical function where a equals 1, h equals 2, and k equals 3. So right now, go ahead and select the right answer. That correct answer be f of x equals, a is 1, so I do not need to type it, square root of x minus 2, and outside the radical sign will be plus 3. So that was the correct answer to that one. Okay, so let us look at that graph. So again, let me just retype it. Let's look at the graph. Oops, wrong spot. Square root x minus 2 plus 3. All right, so what do we notice here, right? We've shifted the graph 2 spots, okay, to the right, and 3 spots. What do I mean by that? Let me just put that parent function back up there. Y equals the square root of x. Okay, so in blue is the parent function. All right, so what am I doing from that critical point? 2 right, 3 up. All right, they're going to match my h and k. That critical point is going to be my h and k. All right, talking domain and range, right? Where's the graph? What's the smallest x value? It's 2. So the domain is going to be everything greater than or equal to 2. right? The range, what's the smallest y value? 3. So it's going to be everything greater than 3. So y is greater than or equal to 3. Right? So what is the critical point? Again, so we just saw it on the graph. That critical point is 2, 3. And another way to always remember that, you don't need the graph to see the critical point. The critical point is always HK. Okay? H comma K, no matter what. Okay, the domain and range, how do you type that in? All right, so using interval notation, right? The domain starts at H and goes up forever. So it's going to be, and it's included, so it's bracket 2, comma, infinity. All right, and then the range is going to start at the K and either go up or down. In this case, A is positive, so it's going up. So it's everything greater than 3. So including 3, so 3, comma, infinity. We have our range, okay? So we could also use inequality notation, but for now we'll just stick with interval notation. All right, so now in the video, go ahead and answer this question. What is the critical point? And the critical point you should have selected should be 1, comma, negative 2. And H, comma, K. H is positive 1, remember the opposite. Okay. Another one, go ahead and select the correct critical point here. Right, so I don't really care about the A when I'm doing the critical point. A is going to affect my rate of change. All right, so the critical point here that you should have selected is negative 5, comma 1. Here's the graph of that function. Notice it's going down. Why is it going down? Because my A is negative. All right, so now it's down 2 over 1, down 2 over 3, down 2 over 5, right? So that's what A is going to control here. It reflected it, okay, over the line y equals 1, the horizontal line y equals 1. Okay. So that's what I kind of just talked about there. How did negative 2 affect the graph? So again, right, it reflected it, so now it's going down. If this was positive 2 really fast, right, it's going up. Make it negative, it reflects it, all right? And then it stretched it out as well. So now instead of down 1 over 1, down 1 over 3, now it's down 2, right, over 1, down 2 over 3. So that's how it's going to affect it. Okay, what's the domain and range? Okay, so go ahead and select the correct domain. So the domain again starts at H, so it's going to start at 5 and go to infinity. All right, what's the range? All right, so this one, go ahead and select the right answer choice. This time the range is going down. Now K is the highest value, it's the maximum, so it's everything below 1. Now remember, when I write that, I got to go in order, so I got to go negative infinity Just type that. Now I got a bunch of stuff going on. There you go. Negative infinity, comma 1. And put the bracket around the 1, right? Because it's included. All right, so here's the graph. I want you guys to select the correct function that matches this graph. And what you should have selected, okay, is going to be, look at the A, right? It's up 1 over 1. So A is 1, so it's going to be x minus h. So h is negative 2, so plus 2. And then it shifted up 3 spots. So you should have selected the square root of x plus 2 plus 3. Okay, again, select the correct function. All right, and so here the h is 1, okay, k is 3. But this one looks like it's stretched out a little bit. So what's my a going to be? All right, so it's up how many and over 1? Right, so let's go over 1 first. How many did I go up? 2. So my a is going to be 2. So it's going to be 2 right, times the square root of x, and shifted to the right, so -1, and then up 3 plus 3. So the correct answer you should have selected was 2 times rad x minus 1 plus 3. All right, last one, select the correct answer. So since this one's going down, you better selected one that had a as a negative, and this one looks like we're going down a half over 1. So a is going to be -1/2. Rad, whoops, rad x, okay, minus h in this case. What is h? H is -2, so it's going to be +2. Gets it to the left 3 spots, and then it's up 5. Up 5. And then there you go. So the match. The correct answer you should have selected was -1/2 rad x plus 2 plus 5.